Hello mathematicians, hope by the end of this video you can say I can use the properties of exponents to apply operations on numeric expressions written in scientific notation. We're going to look at a couple of different examples in this video. So we're given 8.7 times 10 to the power of 8 times 3.2 times 10 to the power of 3. So just a quick little side example just to refresh our memory on the properties of exponents. Let's say we are multiplying two monomials times each other that include exponents. So let's say we have 3x squared times 2x to the power of 5. What we would do is that we would multiply the coefficients together, right? We'd take 3 times 2, which would give us 6. And these have the same bases. They both have bases of x. So we'd take x, and then we would add 2 plus 5 together, and we would get 7. So our answer would be 6x to the power of 7. Well, let's kind of apply that reasoning to these numbers written in scientific notation. Let's think of these numbers in front right here in scientific notation as kind of like our coefficients. So we're just going to multiply those together. So we would take 8.7 and we'd multiply that by 3.2, and then so we do that, and then we would multiply that times 10, and think of this as like the variable as the x in this problem. So we take it times 10. They have the same bases. They both have bases of 10. So 10 to the power of, well, 8 plus 3 is 11. Okay, so let's just do a little side math here and figure out what 8.7 is times 3 point. So we get 27.84 times 10 to the power of 11. Because 8.7 times 3.2 gives us 27.84. So in order to convert this to scientific notation that is proper, we would move this decimal place over one place. That way this whole number is less than 10. And if we move this to the left, we actually need to add one more to the exponent right there. So our final answer would be 2.784 times 10 to the power of 12. Let's look at another example. Now we're involving division. We're trying to find the quotient of these two numbers written in scientific notation. And let's again, like our last problem, let's kind of look at an example of two monomials being divided from each other. So let's say we had 9x to the power of 5 divided by 3x to the power of 2. Well, again, we would take our coefficients and we divide them from each other, and 9 divided by 3, that gives us 3. And these have the same bases, so we get 3x to the power of 3. And that would be our final answer right here. So let's kind of apply that same reasoning over here. So we take 3.12 and we divide that by 2.6. And we do that first. And then it'd be times 10 to the power of, well, now we'd take 8 minus 5, which would give us 3. So it'd be 3.12 divided by 2.6 times 10 to the power of 3. And let's find out what this quotient is over here. And now you got a final answer of 1.2. So our answer would be 1.2 times 10 to the power of 3. And that would be our final answer. So that is it for video. Hope after watching this and getting a little bit of practice, you can say, I can use the properties of exponents to apply operations on numeric expressions written in scientific notation.